Hi and welcome to another very exciting tutorial. What we're going to create today is mind-blowing. So what we have here is a simple application. It displays an image and a title. But the crazy thing is the title was automatically generated based on the image. So what we're doing is visual recognition. And that means that we can insert an image, a randomly chosen image, into our application, and I'm choosing another randomly generated image, and it figures out this has something to do with a crowd. And indeed, there is a crowd. Let me do it again. And again, we have a picture that displays something related to sea, and again, we have something related to city. And this is really amazing, and we're going to use IBM's Watson for that purpose. They have a mind-blowing framework for developers, and this visual recognition part is only one piece of it, but we're going to use it, and I'd like to show you how right now. And to get started, let's have a quick look at IBM's website about visual recognition. This is all part of the Watson Developer Cloud, and you have a lot of other great features there as well, a lot of services that you can use for your apps like text-to-speech or speech-to-text or whatever you need. And here is a great description of what we actually do. We understand the contents of images. We can create custom classifiers to develop smart applications, or create custom collections to search for similar images. And if you have a look down to the pricing, what we can do for free is classify up to 250 images per day and train a custom classifier using 1,000 images. Image classification costs about $0.002 per image, and so on and so on. The complete Watson Cloud services aren't free, but depending on your application, I think it's well worth the price here. And to get started, what you also need to do is start free in Bluemix, which is IBM's developer platform. And what you can do here is sign up and generate a API key for Watson and for visual recognition. Once you have that, you can create your iOS application. And the second thing we need is actually the iOS SDK to use Watson's visual recognition service. And there is a great iOS SDK for all of Watson's services on GitHub. You have to download it or build a framework using Carthage, for example. And there is a video which you can find in the top right corner right now that shows you how to use Carthage to build a framework which can be included into your project. And we need both the Watson framework of the visual recognition framework in our project, and we also need another framework which is called Alamo Fire, and this is for network connections because we want to download images, and this makes it just a little simpler. And I have already prepared those frameworks for me in a Carthage folder so that I can use it nice and easy in this tutorial. So we have Alamo Fire, we have Alamo Fire Image, we have RESTKit, and we have the Visual Recognition version 3, and Visual Recognition version 3 needs the RESTKit framework. So all the links that you need for those frameworks and for all the libraries that we're going to use in that video are down in the description below. And if you do not know how to build your own frameworks, have a look at this video on how to use Carthage to build your frameworks, and then it's going to be very easy to integrate them into an Xcode project, which we are going to do right now. So I'm creating a new Xcode project, a single view application. I'm going to call it Visual Recognition or Watson Visual Recognition. Click Next and create that on my desktop, and I'm going to make my window a little bigger. And the first thing we should do is actually also include this this Carthage folder in our project folder. So I'm bringing up my Watson Visual Recognition folder right here, dropping that to my Watson Visual Recognition folder, and there's my Carthage folder, my build folder, and my iOS folder. And there are all the frameworks that we're going to need. So all we need to do now is drop all of those frameworks into our Xcode project. So this is about all the setup we need to get this going. And then we can create our user interface. And this is really, really simple. So I have my main storyboard, I have my view controller. I'm going to embed that into a navigation controller so that I'm able to add a bar button item for generating my random images. So I'm typing in bar button item, adding that to my navigation bar, selecting a specific system item, which is camera, and that should do it for our purposes. And I'm going to add a image view to my view controller. So I'm resizing it, bringing it down to the bottom, making it the same size as the screen, and also increase the size so that it fits directly to the top. And then I'm setting my auto resizing masks here, making sure in the size inspector, making sure that my image view resizes when I'm using different screen sizes or rotating my device. And then we will bring up the assistant editor for the for connecting our button, which I'm going to choose a connection for, which is an action. Call that get image. With that, we have our button connection, our action, and we also need an outlet for our image view. Let's just call that image view. And with that, we are completely done with the preparation. So let's close the assistant editor and open up the viewcontroller.swift file. And we're getting started by adding or importing everything we need. So first of all, we need the visual recognition framework. So visual recognition version 3, we're using Alamo Fire image. And with that, we are done importing anything. And then we can define two constants. First of all, our API key, which I'm going to insert later. And also what we're going to need is a version constant, and here we're simply entering today's date, which ensures that the newest version of Watson or the newest version of IBM's visual recognition is used, and we're simply giving that as a string to our SDK. And with that, all the preparations are actually done, and all we need now is an image for our purposes. And the image is coming from Unsplash It. So Unsplash It is a great website or a great service, actually, which gives you dummy images for different purposes. So you can use unsplash_it/200/300 to get a dummy image of 200 by 300 pixels. And this is pretty cool. And what we also have is getting a specific image. So here's a list of images that we can use. And we're simply selecting randomly one of those images for our application to determine what's displayed on that image. The reason for that, why we're using that, is because the image needs to have a URL. And if you want to use images from your users, you simply have to upload them somewhere using Firebase, for example, to have a location where you can get a URL from to feed that to the visual recognition service. But since we want to deal with the visual recognition and not with uploading images, we are simply using this URL here that gets a specific image for us. And I'd like to say, let's go back to Xcode and to our get image function. And this is the URL. And we want our images that we'd like to display with a size of, let's say, 400 by 700 pixels. And I do not want the first image all the time. So we randomly want to choose what image we can use. So we have to create kind of a random number generator here. So let's use random number constant right here that gets generated every time we press our get image button. And all we need to do here is using arg for random, uniform, and set an upper bound, which is 1,000 in our case. And then we can cast that to an integer. And we can then use that random number for our URL. So let's define that URL right here, URL, initialize that with a string. and we simply insert our Unsplash URL right here and replace this 0 here with a string interpolation of our random number. And with that, we have always a random number inserted into our URL, and we're getting random images. Now let's just unwrap our URL so that we can access it more easily later. And it's now time to add images, or to download images. And since we're using Alamo Fire Image as our image processing library or image downloading library, this is pretty simple. All we need to do is taking our image view and call the af_set_image function. This takes care of everything we could think about, like caching, downloading, and so on and so on. So all we need to do is inserting our URL right here. And if we run this in the simulator in a second, let's see what happens. So bringing up the simulator here and clicking or pressing on our photo button, and here we go. We have a randomly chosen image. We can press again and we get 1 of 1,000 randomly chosen images downloaded in the background and inserted into our image view. So this is pretty cool. And now it's time to add some more functionality to that. First of all, we do not want our user to tap on the button while a image is just downloaded in the background. So what we'd like to do is disabling the button once we pressed it for the first time. So we get a button constant right here. We take the sender from our IB action function here and convert that to a UI bar button item. And we can then use that button and simply use the isEnabled property and set this to false. And later we're going to reactivate that depending on the process of our recognition of the image and so on. And now we are actually ready to create a visual recognition object, and you're going to see how easy really it is to use visual recognition from IBM's Watson. So we're creating a visual recognition object and simply initialize it with visual recognition. And there are two simple parameters here. First of all, our API key, and second is the version that we already specified. And with that, we have defined a visual recognition object that will do all the work for us. And what this, we're later going to call a function of visual recognition called classify. And this classify function requires us to insert an image URL and also a failure function, or a function that handles a failure of the visual recognition. So let's define a constant right here, call that failure, and we're going to add a function right here. This is going to have an error properties, so error object in, so simple closure here. And what we'd like to do here is first of all print the error so that we know what the problem is exactly. And we also want to update the user interface. Since this is happening in the background, we need to do that on the main thread and explicitly tell our application to do so. So we take the dispatch queue, take the main thread, and tell it to perform something right here. And the first thing we'd like to do is use the navigation item and the title and set it to image could not be processed. All right. And then what we can also do is take our button, set isEnabled to true again, since now we should maybe select another image. So this is our failure function that we can add later. And now we should also think about the URL or the image that we're downloading. The visual recognition API has no problem with small images or detecting something if it's small. We want to display quite huge images so that it looks nice. So what we should think about is reducing the size of our image for Watson's visual recognition software, since we can only send to it files that have a file size smaller or equal to, less or equal to 2 megabytes. So what we do is we define another URL. Let's call it maybe recognition URL, and initialize it also with the same URL we used before, but let's reduce the size to 50 by maybe 100 pixels. Since we're using the same random number, we get the same image, but Watson will have less problems, or we will have less problems if we do not reach those 2 megabytes. So enough with the preparations. Let's now use our visual recognition object and classify the image from our URL. This function call does not give us enough parameters, and this is the complete implementation of this function, which has all of the parameters that we could state. Since these are too many, we are simply defining our own function call here with exactly the parameters we need. We need the image, we do not need the owner, we don't need classifier IDs, and so on. We actually just need the failure block and also the success block that gives us an array of classified images. So what we do is we first of all define our image parameter, which is our recognition URL as absolute string. Since this requires a string, we're just taking the absolute string value of our URL. Then we state the failure function, which we already defined earlier. And then in a simple trailing closure, we can get our success block by specifying one parameter or one argument here that we can use, which is classified images, which is an array that we can use right here. And we need to check if there is a classified image available for us. So we're using the if let statement. Let's call the object classified image, and then we can take the classified images array, which should be lowercase, and this has again an array of images where we take the first one, and with that we have a classified image, and we can already print the classified images classifiers. And if that does not work, what we should do is tell our user that we couldn't determine what's depicted on the image. So again, we have to use a dispatch queue main because we changed the user interface, and this should always happen on the main thread. So what we want to do is use self, navigation item, and the title, and set could not be determined, maybe. And what we should also do is use our button again, and set is enabled to true. All right, and now we can actually run our application for the first time. So let's try that out. Let's choose an image. And here we are. And as you can see, this is our response, and we already get the response sky, which is pretty cool, but we can't really use that response. And if that didn't work for you already, don't forget to add your personal API key. I just added it in the background. So let's now create a more user-friendly output. And what we need to do for that is again create an if let statement for the classification. And if you go through the output, then we will have a we will use our classified image. And from the classified image, we use the classifiers array. And from the classifiers array, we're going to use the first object. Then there are classes in that object. And from that array, we take again the first and then the classification, which is the string that we can use. This seems a little complicated, but if you have a look at what you get here, and I recommend that you do that, then it's going to be pretty clear that you can also choose the different results that you maybe get, because as you can see, you have multiple classifications. Maybe you have beach and you have sky. But for these demo purposes here, we will simply go with the simplest approach here, and this means that we're going to continue with our new classification, and we can then again use our dispatch queue main async and change self navigation item and the title to the classification string classification. And then again, we will enable our button. So is enabled, set this to true, and let's build that. Let's run that. And let's see if we get classification. So I press on my photo button, and we get something, and this is tool. Pretty cool. So let's do it again. And now what do we get? Fog. And I think this is so amazing that in under 20 minutes, we create an application that can perform visual recognition. Of course, we used powerful technology in the background, but I'm sure that you can use that for a creative application. And if you like, you can share your creations in the comments below. Thanks for watching, and I'll see you next week.